Awesome. Right, okay. You're determined to leave me in the dark, aren't you? Right. Awesomes. Nope. Fuck, which one was it? Oh, that's it. Fuck. How the crap? Oh yeah, present. That's the one. Woohoo! Is this everybody? Is that everybody? Is anybody else to come, do you think? Or? Awesomes. Okay. No, right, this talk, is that too loud? Are we good? Is levels good? Okay. No, this talk is a talk I gave. Well, there's two parts to this talk. The first part is a talk I gave to Oshug in Hebden Bridge in the UK, open source hardware user group. So a group of people very much like yourselves, very much hardware hackers, but probably not from the sort of badge community. Some of them are Hackspace members, some of them are industry people. So it's a slightly different audience. So some of the things you will already know. The second part is I want to talk about something else on the same subject, but we'll get onto that. It's titled "Saving Your Electronic Conference Badge from a Life on the Shelf," because writing for Hackaday. Sorry, I should introduce myself, even though you probably all know who I am. My name's Jenny List. I write for Hackaday. I'm also a member of Oxford Hackspace and MK Makerspace in the UK. Writing for Hackaday, I see a lot of badges. And obviously, we cover badge life to a great extent. It's one of the more exciting things that we write about. And the trouble is, you see a lot of badges which were really cool when they came out, but aren't really much use now. They're nice to look at, but not much else. And you come to the point where you realise that it's a shame. So this is sort of, I guess, a personal manifesto. Now, this is the bit where you probably know this stuff. Quick introduction to what is badge life. Most of you will know this because you're part of this scene rather than part of Oshug, but this slide is from them. Obviously, electronic conference badges, you get one when you come to a conference, and it's an electronic showcase of what's possible. That's the first ever electronic conference badge in our community from DEF CON 14 in 2006. It's quite simple. It's a DEF CON logo with LEDs for eyes. I believe they had different colors for different types of levels like they normally do. But that's the first of the art. Now, this is very important, the last point at the bottom. I don't know how you lot see badge life, but you may see it as a demo of stuff, you may just see it as cool stuff. I see it as our community's art form. There are plenty of people in our community who do art, but normally they do a hacky version of other people's art. You know, art that you'll find from other people, right? This is the art form that has evolved within our community and is of our community. And this leads on to what I'm talking about later. I feel it's important that we recognise that and celebrate it as an art form. So this is just a quick introduction. Yet again, you probably already know this. The event badge is the kind of thing you get given at an event, like the badge that some of you are wearing at the moment. Art badges are not official badges for an event. So you're probably familiar with the DEF CON badges for DEF CON in the States. They're produced by individual groups, and they're much more sort of expressionate. There'll be LED light shows, there may be games, whatever, but they're usually created as something pretty to look at rather than as a functional item. But I appreciate you're probably familiar with this. And shitty add-ons are little add-on boards that plug into a standard connector. The idea that you can embellish your badge with all sorts of different little add-ons, and there are all sorts of novelties, there are sensors, there are input devices, you name it, it's been made for a shitty add-on connector. But as I say, this is a slide aimed at the OSHA people, so you probably are more familiar with this. And this is coming on to what I was realizing, that I had a drawer full of badges. I mean, badges are great, we love badges, we want lots of badges, badges everywhere. But the trouble is, when you come home from an event, you think, wow, this is really cool, it's a hackable badge, I can do stuff with it, and it goes in the drawer and gets forgotten. And I think probably most of us have got quite a big drawer full of badges, and they come out every now and then, you say, oh yes, I remember this event, or you know, you sort of wander around the sort of statement that I was cool, I was at this event. But the point is, how many of you use random badges? You know, we've all got badges which were cool on the day, but have you done anything since? And this was just some of the ones of mine. I think there's one there that I borrowed from a friend for something, but you know, great big box full of badges, which is, I just felt was a shame. So this is a personal manifesto. Now, and it's a bit difficult really because I'm an electronic engineer, but I'm a journalist. I'd love to do my own badge, but I haven't had time. So I'm talking to people who actually make badges here, and I don't make badges. And I don't want to be standing here saying, yes, this is how you should make badges, because I don't make badges, and I'm going to tell you how to do your job. So this is it's a personal manifesto of what I would like to see in future event badges, with an eye to making them more useful in the future. I don't want people to sort of take it as me telling you how to do your job. You feel free to tell me to sod off. This is my thoughts on what I'd like to see. As I say, this was written for a slightly different audience, so I don't want to sort of, I wasn't talking to badge team people, for instance, when I wrote this. But the first thing any badge should do is be useful. Now, most event badges are useful. So at the event, you fire it up and you get the event schedule or whatever other event-related apps. But when you get home, the event schedule's not much use, unless you want to sit there and page through 10 little menus to sort of reminisce about how wonderful that, can I read what that talk was? It's not much use. So you want something that 3 months later, what will this badge be useful for? Now, this is one of the badge team members did this. It's a little demo weather app. That's a brilliant example on a SHA badge of something that's useful after the event. It's using it as, in this case, a weather display. It might be something for an IoT thing or whatever. You want to think, how will my badge be useful after the event? Even a clock. I mean, there's badges here that have clocks on, you know, if you use it as a clock. Or if you have something that is driven by an online source, make it an online source that isn't only specific to the event. Make it something so that if you have a weather thing, it doesn't just tell you the weather at Scoutingland, Scoid, Zeewolde, it tells you the weather in Oxfordshire, where you live, where I live. So that's what I want to see, but it covers not just the software. It covers software and hardware design. So for instance, I'm skating on thin ice here because some of the people who made this are in front of me. But this is a SHA 2017 badge, right? Software-wise, great, you can put your weather app on it. This is quite good because it stands up quite nicely. There are other badges which don't stand up so nicely, you know, have a curved bottom or whatever. And I believe somebody's made a 3D printable little stand, you can see there. So that sits nicely on the desk. But this is a good example of something that gets nearly right, but the sort of the sort of thing you've got to think about. And the thing is, this is something that was written for a different audience, right? The power lead is on top. When I have this sitting on my desk, I have a great coily cable coming out the top. if the power lead were on the side. So that's a little example. This is a fantastic badge. This is one of the best badges I've ever seen. No, the point is, well, we all know, I mean, come on, we all know this is a fantastic badge, right? Yeah. No, we all know this is a fantastic badge, but this is a little example of a tiny design feature which is the sort of thing that when you're making a badge for useful in the future, this is the sort of thing to think about. And you know, I'm walking right into the lion's den by you know. But this is a pertinent example because it's an example that I think everybody will understand, and it's not a sort of terrible criticism. God knows there are badges I will criticise, but you know, this is a good quick example of a little design change, which you know. Anyway, well, I guess you could, but then you'd have to sort of read it. No, I know. Yeah, you put Hacker Hotel Firmware on it. Job done. The other one is Be Hackable. Now, somebody here today has an EMF badge, right? Now, EMF badges are brilliant, beautifully designed, right? The problem they have is that if you want to write software for an EMF badge, you're instantly into elite stuff, right? Now, you have to download a toolchain, a great arcane Linux toolchain, which takes quite a long time to sudo apt get installed, blah, 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 and then you sit there for whatever. And then you've got to know how to use it. You've got to fire up whichever text editor or whatever. And there is a massive barrier to entry for developing for it. And then once you have written your app, you then had to supply it to the badge people for EMF who would build it into an official firmware, and then it would go on the badge. And that wasn't very hackable. Surprisingly enough, it's not always that way. So for instance, the Born Hack badge in the summer, it's a little Cortex M0, was it? Maxim, was it? I think it was a Maxim Cortex M0. And for that, the toolchain was actually surprisingly simple. They'd done a really good job there. I was even able to install the toolchain on a Chromebook, which absolutely shocked me, and I was able to write my little Hello World app. So it's not always that way, but if it is easily hackable, it's usable after the event. Now, of course, coming back to the SHA badge, this is where the SHA badge and its descendants score beautifully, because you can go onto the hatchery. I want to say App Store, but you know, hatchery. You go to the hatchery and bang out Python and actually get it onto the badge. The flip side of this is, of course, when you do that, the world and dog can see your crappy software before you've got it right. But well, yes, that's true. But you know, the trouble is, I mean, I'm not elite. I count myself as 1336.5 because, yeah, I can normally get something like this working. But if I have problems with a tool chain, what hope has a Windows user who's come in because they do some, you know, they have a slight interest, but they're not a software person? And I think I wrote that down. An ideal badge should be hackable with minimal effort using something the recipient already has, a web browser or a USB MicroPython, for example. But the bottom one is actually very important. Documentation. Now, I'm going to tell you a little story about a hacker camp I went to in 2017. Right, this is actually a very easily hackable badge, as you know, right? I sat in the British village, and we were sitting there for about an hour. And will you believe it, none of us managed to get our code onto this badge. And this is really embarrassing to admit this, but you know why? It's because we all had it plugged in, and it said on the screen that it was at the loading screen, and we were waiting, you know, trying to connect, and it wouldn't connect. And what we hadn't realized was that if you leave it, it goes to sleep. But because it's an e-ink screen, and that was actually a documentation thing, and I appreciate the documentation now says that. But at the time, none of us had found that. And so, believe it or not, we sat there for ages and couldn't get any blooming software on this badge for something that simple. So I know I say this because I'm a writer, but documentation is as much part of the user experience for making the badge hackable and giving it a life after the event, because if you can't, if your average Windows user or whatever can't figure out how to talk to the badge and how to get software on it, it can be the best badge in the universe, and they'll be sitting there frustrated and they'll move on. It also has to, well, there's another, I think there's a thing I haven't put in here, which I should have put in, but this is too insulting. It has to work. Now, I don't have one here, but you're probably familiar with the radio badge from Chaos Communication Camp 2015, right? I had a big argument with one of my colleagues who was at Chaos Communication Camp 2015. I wasn't at CC 2015. To him, the radio badge is the best badge ever. And it is, it's a wonderful badge. It's got a software-defined radio on a badge. How cool is that? And to him, everybody was hacking their badge, and it was really cool, and you've got a software-defined radio and everything. It was the most wonderful badge ever. To me, I wasn't there. When I wrote a piece about badge life for Hackspace magazine last year, I asked a bunch of Hackerspace friends, hey, you went to CCC in 2015, do you have a badge I can borrow? And I was offered 5. None of them worked, because they either hadn't worked out of the bag, the firmware had gone wrong somehow, or other things that these people are, they're not my sort of Windows user. They are power users. They would have expected to get things working, and they couldn't get their radio badge working, which is such a shame because it's an awesome badge. And in a way, this is where I had my argument with Elliot, my colleague, that to him it's the canonical awesome badge, and to me it's the canonical badge that didn't work. I mean, I know it's difficult, it's hellishly difficult getting a badge to the hands of the users. And it's something that Shah did brilliantly. I mean, we had a working badge delivered day one, yeah. But it's almost a cautionary tale that if the user can't use it, then it's never going to get used after the event either, which is horrible to say because I'm treading on the most vulnerable toes of any badge developer. But anyway, expandability. So many badges don't have anything to plug into, and a large amount of badge hacking is the hardware side. And I have some yet more sort of personal manifesto ideas on that, which I want to share. That's the EMF badge. That's a 2016 one. That's probably one of the most expandable badges that I've been given because it's absolutely covered in interfaces. Well, it is. You know, it's got a port expander. It's got a load of GPIOs. It's got these crocodile clip and 4mm jacks. It's got a bunch of other sockets on the back. But unfortunately, so many badges just don't have anything. Or when they do, they have proprietary plugs. I mean, normally nowadays they'll have a shitty add-on. Is shitty add-on I2C, I believe, isn't it? Yeah, and 3.3 volts. They'll have Grove, which is, yet again, one of the serial things. They'll have a proprietary pinout. So, for instance, it's got a proprietary socket on the back. Or some of the older badges had Arduino, classic Arduino pinout, which is standard, obviously. Now, I'm going to make a plea to badge designers. I appreciate that classic Arduino is very dated nowadays, but I would love to see more badges with a standard pinout. I would suggest maybe something like Adafruit Feather, something like that, but something where the punters have a reasonable chance of having something they can plug into it already. The reason is, I'm sorry, coming back to this one I went to in 2017. There was somebody produced a prototyping board for this, and I didn't manage to get my hands on one. And now they're all gone, and there's nothing I can plug into it. Now, obviously, I can get a bit of strip board, which is basically what I've done at home. But so many badges, the EMF one as well, there's nothing can plug into it. You have to sort of have dangly wires off it. And to have something like feather wing, or whichever other standard one they are likely to have, again, makes such a difference. So yes, this is a personal manifesto plea. If anybody is thinking of making a badge, think in terms of that expandability, because I think that's something that will make a difference to make it usable by people down the line, if that makes sense. And then support and maintenance. Now, the example I sort of used to describe this is actually, well, most of you are sitting in front of me. I mean, we've all got badges where the last firmware update comes on the last day of the camp and that's it, and it doesn't work. Now, coming back to that camp I went to in 2017, I mean, I believe, was it the last update on this was about a few weeks ago now? And I believe, are you promising to release them until 2021? Yeah, and there'll probably be more after that. So I mean, I'm preaching to the converted here, obviously, but it's so important, and it's the thing that makes me excited about Badge Team, is the fact that you have the continuing ongoing support and the App Store, which means that if I go back and look at the SHA, I don't know, I should have looked before I went, what the most recent app for the SHA 2017 badge is in the hatchery, but there are some that are quite recent, aren't there? I mean, I think I updated the Hackaday one quite recently.
6 minutes ago.
Impressive, yeah. But the point is that's for an event that's nearly 3 years ago. And how many other events are there like that? There aren't any. Well, yeah. But the thing is, this was written for a different audience, and I'm actually talking to the people I'm talking about here. So this is a kind of a redundant slide today, but hey, you get to sit through all of them. And the last one is fun. Now, you all know the Camp Zone badge. This, in a way, breaks all the rules I've just talked about. Well, no, it does. It does. It's not expandable. I mean, okay, it's got the support and everything like that, and it's not the most, how should I put it, not the most high-resolution display, whatever. But you'll be seeing these badges round people's necks for years to come. They're about to do a second run of them, aren't they? They will sell like hotcakes. I walked around. I mean, I'm pretty sure you've all seen this badge, but if you haven't, I walked around Chaos Communication Camp in the summer with this after dark, Nyan Cat. And I had a constant stream of people coming up to me saying, what is it? Where do I get one? That fun thing means that this and badges like it will have a continuous life for years. I mean, if I go to a hack camp in 10 years' time with this around my neck, I'm sure I'll still have people coming up to me asking me where I can get one, if they don't already know what it is. So that's the elusive ingredient that everybody tries to get, and sometimes people fail. I mean, when I gave this talk originally in Hebden Bridge, I brought along a big sort of show and tell. And actually, one of the examples I used to, this is eating your own dog food, one of the examples I used for what not to do on a badge was actually an amazing badge. It was the Hackaday Super Conference badge 2017, because it breaks so many of the rules. It's got no ongoing software support, it's not expandable, it's got all the things. But unfortunately, eating one's own dog food when one hasn't got the badge is difficult, so I've had to eat somebody else's dog food. But if you look at some of the other badges I've been able to randomly borrow, probably most of you will be familiar with the Hack Hotel badge. I borrowed one. It's very similar to the SHA badge. It's got a Grove connector for expansion. Sadly, it would be great if it had the same expansion as the SHA. I appreciate that's a cost thing, isn't it? You know, you can only put so many components on a badge, can't you? The Disobey badges, yet again another badge team badge, but designed Finnish, aren't they? Yep. Yeah. This one, unfortunately, does it have any expandability? Is that an expansion connector? I don't know this badge very well. I've only just borrowed one. Yeah. Well, no, you need to be able to plug it. The trouble is, this is the first time I'm handling a trooper's badge as well. Oh, that's got a grove. Has this got any other headers? I mean, I like this one. This one's got a QWERTY keyboard. But I know they always have this shield shape, but it doesn't stand up on the tape. Do you think this would be used after the event? I don't know what the firmware that this one's been hacked with badge team firmware. Yeah. Was the firm? The original firmware didn't actually do anything except show a nickname. Okay, fair enough. But of course, I'm going to save the most fun badge till the end. These badges are all very good, but will any of them open a beer bottle? Right, now that's the talk. Unfortunately, it's a slightly truncated version of the talk, and it's a slightly sort of embarrassed version of the talk because I'm talking to people who have more of a stake in the game than the previous people I was talking to. But we come on to the second part. Now, I went on at great detail about how I consider this to be our community's art form. I genuinely believe that at some point in the future, there will be somebody in the art establishment, somebody of the sort of Damien Hirst kind of variety, some recent graduate from the London College of Art or wherever the equivalent in the Netherlands is or wherever, will discover printed circuit board art. And suddenly, well, no, but you will. I mean, you'll suddenly see sort of galleries and people paying vast amounts for PCB art and badges, and all the hacker community, we thought of this first. And I want to say, we need to take ownership of this. This is something that we as a community can be very proud of. So next year at EMF camp in the UK, I'm going to put in a proposal for a badge museum, or a badge art gallery, a museum gallery, not sure what to call it. And what I want to do is, I'm going to put this to John T. I'm going to ask him for a grant to pay for like a marquee and some tables and stuff. Probably we'll have to make some display cases. I want to make it as close to the museum experience as possible. I don't want it to just be a sort of random tables with badges. I'd like there to be badges that you can actually interact with, but I would like to tell the story and the history of badges. Now the problem is, I can't do this on my own. I need other people to help me, because it's actually, as much as a display problem and a staffing problem, it's a logistical problem. I have to go round to as many people as I can who are going to have awesome badges. So for instance, like the DEF CON badge life scene badges. And I'm going to have to say, look, you have this really valuable and rare badge. Can I borrow it and stick it in a field in England with a bunch of people looking at it? And I have to persuade them that that's a good idea. If I can find somebody who's got a 2006 DEF CON badge, I want to borrow it. And it's probably one of those things you have to stick in a glass case with lasers and security guards or something. But that's the kind of thing I've got to do. I'm probably going to ask my editor at Hackaday for some kind of sponsorship. I'm probably going to see if they will pay for insurance and shipping for those kind of things. This is something that, if it works, I would like it to appear at future camps. I would love to bring it to Meh, or whatever it's going to be called. Well, no, it's our culture. It's a celebration of our culture. So I would like to bring it to whatever camp is coming up. And it's something that I don't think should be Jenny List's Badge Museum. I think it needs to be owned by the community. So I was hoping that something like Badge Team, but if not some other community-based organization, would be able to take ownership of the name and the idea, rather than it be sort of my thing, if that makes sense. I would like to bring this together as a group of people to try and plan this, to be able to have it ready to go, arrive on the scene, unpack boxes, put it all up, display boards, the works. And I'd like it to be an experience where you feel like you're walking into a serious exhibit. I'm this is something I've been thinking about only for the last week or two, so it's something that isn't fully formed. I was thinking of possibly opening maybe a dedicated Slack channel or similar, or actually you guys use Telegram, don't you? Yeah, okay, probably a dedicated Telegram channel. I'll tell you what, I'll set up a BBS and you can dial in. Keep it old school. Now, I'll set up a BBS and we can all use a bulletin board. The scary thing is this has probably got the processing power and the networking to run multiple BBSs at once. Now, there is a challenge for one of you. No, but I can, but I yeah, but I consider this to be an important thing. But I realise that I can write a proposal, I can do a certain amount of the stuff, but this is something that will need a bunch of people. So this is kind of a pitch for if anybody is interested in the idea of a badge museum at Hacker Camps. I think it would be good if we could form some kind of group to do it. And I would like suggestions on what badges should be in it. I have some ideas on the sort of themes of the exhibitions, but I'd like suggestions on what badges to put in it, what you would like to see to celebrate it as an art form. So it's up to you really. What do you think? Yeah. Okay. Absolutely, yes. If nothing else, there is an actual bar. Yeah, yeah, yeah. But no, seriously, I mean, I've probably talked to some of you about this already, but I'm canvassing thoughts and opinions and canvassing for people who might be interested in participating. What do you think? I was actually thinking if you think of the way a museum works, there are sort of exhibitions. So, for instance, you would have an exhibition in which, you know, sort of the early origins of badges, and then you might have one that focuses on an exhibition of, I don't know, DEF CON badge life badges, or you probably have sort of all the different badge team badges. I mean, you know, have a sort of an overlapping sort of kind of yeah. Well, you could, but I feel that it's important not just to have a dry, here is a badge, here is another badge, here is another badge, but to have it like a museum would with actual cogently thought out exhibits, if that makes sense. Oh yes, yeah. 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 Yes, yeah, yeah. Well, if there is one thing that I know I can do, it is write copy. That would be nice. I mean, it is an important thing that I know more than one of the people I've talked to agrees with me on this one, that where possible they should be interactive. So that would be very cool if that were possible. But for instance, when you have a SHAR badge, you know, you have your SHAR badge on your little stand with a light on top of it, and you can go out and you can press things on it. And I guarantee it will be measured in femtoseconds before some arsehole puts some bad, you know, virus on it or something. So I expected to say still pwned anyway. But that's an important thing. That's an important thing. Where it is possible, it should be interactive. You just want to look at boobs, don't you? No, but yes, you're right. You're right. Actually, having, sometimes there is a context where it works better displayed on the human form. Or maybe I want a Greek statue with them dangled across. but I mean, yes, indeed, yeah. Yeah. Well, does this fly? Okay. If I set up a Telegram, will you be interested? If I register a URL or whatever, I know that Badge Team doesn't have a foundation yet. Will Badge Team ever have a foundation? Okay. I mean, yeah. I mean, whatever. Yeah. It's the reason I'm asking this question is I don't want this to be Jenny's Badge Museum, because it shouldn't be owned by one person. This has to be owned by the community. This is a community celebration of itself, rather than. How well is this job paid? Yeah. No, but the point is, it has to be something that can, like anything in this community, resilience comes from transferability and not concentration in one place for anything else. Okay, I will go away and I will set up a Telegram and I will write a pitch which I will send to John T. I mean, the more than one person has commented, and I don't think I fully agree with this, I don't think John T would say no. And I've definitely had more than one person involved with Meh saying, yes, we want it. So I would be, if it's possible to make it happen, it would be something I would want to see at future events like that. Yeah. The milliways of Badge Museums, yes. But yeah, I mean, is that good? Yeah. Cool. In that case, I think that concludes what I need to say. And I hope I haven't trod on too many toes by pointing out all the obvious flaws in the SHA 2017 badge.
I think many are solved with a right-angle USB connector.
Well, yeah, that's true. I mean, to be honest, it's very difficult to critique this badge because no. Compared to the other badges, you've done a damn fine job with this. I can't. Okay, I used really tough dual-sided tape. Mine fell off at the event. Mine fell off at the event, and you gave me some very tough double-sided tape, which has held it ever since. Yeah. And mine is also one of the ones with the little bodge resistor, which is absolute hero soldering, whoever did it. But anyway, thank you very much. Thank you for listening, and I will do some action on that.
Hello. Hey, that works. Ah, since we're already 5 minutes over time, let's begin. Hi, I'm Thomas. I'm going to talk about Spectra. Oh, it's try to. Hi, I'm Thomas, and I'm going to talk about Spectra, a device which enables open biomedical imaging for the masses. It's a really, really new product. This is the Spectra itself. It's an actual device, just it's not a technique. It's a Kickstarter, and I was really, really nervous about not giving any presentation or demo at all, because it only arrived last Thursday, just to give you an idea of how recent the device and the technologies are that I'm going to talk about. But first, what is biomedical imaging and what can we do with it? Currently, there is a lot of pushing the boundaries on biomedical imaging on the high-end scale. So I myself work on 7 Tesla MRI, and we do amazing stuff with pushing the resolutions and scan times down to quarter millimeter cubical voxels and super fast sub-second scan times and different contrasts. And that's all nice and all, because we, for example, in the brain, we can discover the newer working mechanisms and layers, and we can do really cool stuff with it, but we don't need to push the technological boundaries in this end to produce cool things. Because, does anyone know what an MRI machine like this costs? Just was wondering. How many? 1.2. No, it's a bit more. No, it's not 10, but it's about $1 million per Tesla. This is a 3 Tesla machine, so the machine itself costs approximately 3 million euros. But then you also need all the space for it and all the servicing contracts. They cost a lot of helium to operate. Helium is getting really expensive. And it's not something which is for the masses, which also shows in the fact that if we take a look at the distribution of imaging modalities across the world, we can see that West Africa only has, I think it was 84 MRI scanners in total, of which 2/3 were in Nigeria, and all the rest are, don't have any access to imaging modalities like MR, which is really quite sad. And it also, we hackers don't have easy access to it. How many are there worldwide? That varies. The States has a lot. We also have a lot in the Netherlands. I think it's 100 per million or so. So it's a lot more than they have in Africa. And then just recently, in popularity, came along EIT. It stands for electrical impedance tomography, and it's a relatively new sort of imaging modality. What it does is it measures electrical impedances and does a tomography. So it's to say it makes a reconstruction of an image with it. And how does that compare to the current modalities we use? So I put up a table with a normal CT, like a CAT scan, MRI, ultrasound, and also I put an EEG as a comparison. EEG isn't really an imaging modality, but it's something that's used diagnostically and also experimentally, for example, in the OpenBCI project. I'm sorry about the fuzziness. The main advantage of EIT is that it's really, really, really cheap in comparison and accessible to all these things. It's not dangerous, it's not big or bulky, and it's hackable. But, of course, since I see a question already. Somewhere light bulbs. No, sadly, Philips Hue is not actually part of Philips anymore. I'll show you some brief pictures in a moment, and I'll do a demonstration at the end. And I think if you slightly remember the second picture of the brain, and if you do a rough comparison, then I think you'll agree that Philips is not in trouble yet, because the images that EIT produces are currently not comparable to the quality that we have. But I think we'll get to that in a bit. But first, since I'm going to introduce it to you as a hacking tool, should first make sure that it's actually safe to use and safe to hack with. So I myself participate in a lot of studies, and I do a lot of medical research things. And And it's sometimes really easy to go into the gray area of which is healthy for you and which is not. But luckily, the Spectra totally complies with EIC 6T601 guidelines because it uses very, very little currents. To measure impedances, it puts out a very small current between two electrodes and measures the voltage between them. And the first currents usually are feelable like around at the 1 milliamp mark, and it's a couple of factors lower because it will never produce currents more than 10 microamps. And the allowed current also goes up with a specific formula as is stated in the EIC regulations. The problem with having very low currents is that you don't get a lot of voltage for a specific impedance. So you need to have very advanced electronics and good ADCs and low noise measurement setups and expensive chips to actually still produce some results out of these small currents. But that's the only way you can do it legally and safely. Which brings me on to the specific hardware that is now available and usable for this. It's a Kickstarter. As I said, it was delivered just last Thursday. And the starter kit costs $349, which sounds expensive, and it is, because the PCB is only 2 inches by 2 inches. But it has some pretty advanced analog stuff on it. Mainly it's powered by the ADU CM350, which is a IC specifically designed for doing these impedance meterings. And it also has a lot of safety features for current limiting, which is kind of handy if you want to try it on yourself instead of just fruits. And it also has some microprocessing powers and some Bluetooth capabilities to actually make it usable and attractive. And then I have a couple of first images. One of these two images is the first image that was produced by an MRI scanner, and the other one is one of the first images that was produced by electrical impedance tomography. I was wondering, which one do you think is which? You can also just use it as an LCR meter. But then it's a really expensive LCR meter. And also, an LCR meters don't usually need 32 channel and a whole bunch of analog multiplexers. It's basically a 32 port network analyzer. Yeah. The chip is also used in basic network analyzers. Very high. I don't have the specs on the slides, but very high. So which picture you think comes from an MRI and which picture comes from impedance? Yeah, nice. You got that right. Yeah. So the left is indeed the MRI, and the right is the impedance tomography. And looking at the current MRI pictures, they of course look a lot better. But the RT picture currently, in comparison to a modern MRI, looks really crap. But if we compare it to one of the first MRI pictures we had, it's actually not that bad. We're just in the very early stages of imaging electrical properties. And it just will take some years and some research to push the new boundaries in that. So yeah, you're right. So how does this work? How do you get a picture of conductivities and electrical impedances? Well, what this thing does, it has an array of 32 channels, and it can produce an AC current, not DC, because AC is usually safer, between a pair of any of these two electrodes, and then measure the current between it. And if you put current through a conducting object, according to how conductive the materials are in between, you'll get a specific sort of current density, which is shown by the blue and blue and black, lines in the tissue. In some places, the lines will be really dense, they'll be squished together because it will be highly conductive, so there'll be a lot of current, and on others it will not. As you can see in this picture, the two black things are lungs, and you can see most of the lines try and go outside of the lungs because air doesn't conduct. Yeah. Yeah. Mm-hmm. 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 True. In principle, you can also do just resistance, but the measurements are usually too noisy. So what you preferably do is a frequency sweep, so you can actually map out all the tissue parameters. You get another dimension, basically, of data. In principle, resistance is fine, and basically, indeed, impedances are a lot nicer. But the main problem why resistances are not used is basically noise, because if you put in an AC signal and you measure the same AC voltage back, you know that you're exactly measuring impedances instead of just static noise that you pick up. But yeah, indeed, AC is a lot more interesting, but mainly because it adds noise resistance and more data. To make an image, we already have a quite nice understanding of how these paths will flow to different objects, and luckily we already have a lot of algorithms and a lot of technology in place to reconstruct these images. It's an inverse operation, and it's almost the same which is being done for CT and MRI. So the back projection method is exactly the technique that CT scanners use, or CAT scanners, to make images. And we can use the same techniques to produce an image of impedances. And how that works is, as demonstrated in the picture, you measure all the pairs of electrodes that you have available. Of course, that scales up really quickly at the number of electrodes. And you basically get lines of where current can flow. You do sort of back projection, you solve the inverse problem, and then you get the conductances out of you get a picture with conductances of your object. You can also do some more interesting stuff because you're using AC. You can do spectral analysis. You can do sweep up to the spectra does from a couple hundred hertz to a couple hundred kilohertz. And different materials will have different impedances at different frequencies. For example, this is an apple and a sweet potato, and you can see they're very clearly indistinguishable by their responses to different excitation frequencies. In this case, the difference is quite huge, but you can also use, for example, cooked and uncooked food, or meat in different stages of being cooked, and you can use the impedance of, for example, your meat to at different frequencies to determine how well it's actually cooked before you cut it open. So it doesn't have to just be biomedical imaging. You can also image your food and the chemicals in it. EIT cookers soon. I don't think we'll have pans with EITs soon, but I think it would be really cool. I'm sorry? That would be cool, yeah. And lastly, the other type of analysis, which is also possible, is a time series analysis. If you restrict yourself in the number of channels, you can also use that one channel continuously and then make impedances over time. This is a graph of electrodes going from the back to the front, measuring breathing and heart rate in one signal. As you can see, the small humps are the periodic heart rate, and the big going in and out is the size of the chest moving up and then collapsing down again and influencing the conductivity between the two electrodes, which is a really information-rich measurement, because, for example, you could get both the modality of the heart rate and the breathing in just one electrode pair. Then I figured it would be nice for a demo. Usually demos don't work well, but I was hoping to actually show it. Over here I have the spectra and a small bowl of water. It has a little bit of salt in it to increase the conductivity. Ah, no. That's what happens. Let's try that again. What? Why doesn't it say that? That is interesting. Normally it's supposed to say a port in there, but apparently Flask is not. Let's see if it still works anyway. Okay, yeah, it seems to still work. So first let's try and connect up to it. That seems to work. Currently the device is quite slow because it's outputting over a serial connection all the impedances of all the pairs. In this case, it's not using a full 32 channel reconstruction, but only 16, because of 16 it's just quicker to measure the combinations. If you do 32 channels, there are 892 different combinations that you have to measure, and that takes a little bit of time. That takes like 20, 30 seconds. If you do 16, it's a lot less. So currently you can see this histogram down here. that's a histogram of all the impedances and the amplitudes it measures. We can use this as a baseline because it's now currently empty and calibrated on that. So as you can see, then the spread becomes a lot smaller. Then we can try and put in, for example, an orange and see if that shows up. So the first measurement will be crap because we only put it in halfway. And let's see if we can actually get a picture out of it. It looks like an orange, but that should be a representation of the top view of the ball because all the electrodes are in a 1D plane. And you have to actually keep it still because otherwise the water moves and that also creates interesting things. Oh, interesting. There we have a picture, but also one of the nicer shortcomings of it. You can sort of see shadows because of the back projections. If you put it really close to one side of the electrodes, no current can flow through, and then it will think there are two objects in the same position approximately. And yeah, that's the current state of affairs of using impedances to image. There we go, that's a lot better already. So the resolution is not that great, and the time is also not that great, but it's an open source project. It's called OpenEIT. It's on GitHub, and it will need a lot of more developments, but then we'll have a really cool, hackable imaging modality. Mm-hmm. 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 That's actually, I think, one of the use cases in which it's now being tested with. If you use like 8 channels around the chest and you sort of have a vague imaging modality, you can not image at a high resolution, but you can at least do comparisons between left and right and front and rear. And then you can, indeed, you can check for water ingress if people are lying on their back and seeing if they breathing is one thing, but also seeing if there's actually air going in and out instead of other fluids which shouldn't be in there. That's indeed one of the things that it's now being used for. Yep. Mm-hmm. I think the biggest limitation currently is the software which is in place. The actual code which is running on the device itself hasn't been developed very far in the production time. I think of the Kickstarter. I think that's usually how it goes, right? As soon as the Kickstarter works, then you actually need to ship out the hardware, you need to produce everything, you need to buy everything, and then ship it out, and then afterwards you'll slowly start fixing the software. So I think the software on the device isn't optimal. It's really rather slow, and the measurements aren't well optimized yet. And also the reconstruction algorithms that are implemented here are in its very early stages. Also the fact that it needs a calibration is kind of a shame, because you cannot easily calibrate on human bodies, for example. So there must be some outer calibration implemented, or some absolute references to make easier pictures of stuff which is not a perfect test setup like this. I've heard that one before. I wouldn't see how you were to do that. You would need some piezo, I think, some piezo inducers to actually create sounds and pulses and stuff. And I think you would need a completely different hardware setup for that, because this is designed for really low currents and low voltages, and usually ultrasonic transducers require pretty high voltages to operate.
Another thing is, with the very basics of how back projection works, you cannot have a single pixel or like thing in your scanning area that does not have any information at all.
Mm-hmm.
Maybe you've seen that with PCs, if you have like metal inside an PC scan and the display cannot have this part of the imaging at all, you get very weird artifacts.
Yep.
And I'm afraid that with this technology you get the same problem, right? Because, for example, the orange, obviously, because you can see the shape of the orange, but this measurement method only works for conductive substances, and this orange is covered in peptide.
Mm-hmm. It still conducts a bit.
I think this is very conductive compared to the water. Like
Mm-hmm.
viewers. I would say that the field of the orange is much higher than the one around, and I don't even think with this setup it would be possible, completely not talking about the software, to
Mm-hmm.
make any images of inside the orange, because you have this shell that isolates.
Yeah, of course, if you're isolating shell, then that won't work, of course. And this also doesn't use the back projection method, because the back projection method indeed works very well for conductive stuff and highly conductive stuff. And also, the back projection stuff assumes that signals are always traveling linearly, and as I've shown in the current density picture, currents will try and follow the path of the least resistance, which means it's not in a straight line, which means inherently that the back projection method will never give proper results. You'll need an algorithm which takes into account that currents will curve and take different paths. This uses the Jacobian Newton-Gauss reconstruction, which sort of takes that into account without going into more of the technical difficulties.
But again, because you were saying that you're that you think that in the future this will improve significantly as this technology is now available.
Mm-hmm.
I'm a bit more conservative about it, because like this technology is nothing new. Like we know
Mm-hmm.
for the last 20 or 30 years, exactly the same with MRI and CT. It only now just happens that our semiconductors got good enough that we can pull off a demo that works as good as this does.
Mm-hmm.
Which does not necessarily mean that in 5 years we can do like, we can have the same progress in better image resolution as we had with CT scanners.
Mm-hmm.
Or with MRI machines. Because MRI machines, when they turned up, and research was done, this was actually a new technology, and you could do improvements quite rapidly, because you could optimize the system, you learn new things. But I think with this is like not really new technology, and the image resolution, everything we get, mainly depends on the semiconductor, low noise semiconductor that we can produce. Because as you said, this is like very high quality hardware from analog devices, or
Mm-hmm.
pretty much the best analog hardware you can get nowadays,
Mm-hmm.
and it only produces these images.
Mm-hmm.
So of course you can do some improvements, but I wonder if it really will be of any use for.
No, of course, I also totally agree that this will not replace MRI machines in their contrast abilities and in their geometrical correctness and in their resolution. But then again, there is also a really big price difference in between them. And I think this is a lot better than having nothing already. And I don't think anyone has a personal MRI machine in their backyard, but now you can have an analog devices chip to do smaller scale experiments like this. And I do think that if we go to higher arrays, densities, and if we go through the third dimension, which you can also then do oversampling with and do better reconstruction of the current densities and better reconstruction of your properties, I think we will be able to do a lot better. But it's not a replacement for the current image modalities. And I also think that the reason why it indeed, like the first paper is like 30 years old, but there hasn't been a lot of work going into it, mainly because of that there are no big companies out there investing into it, because I also don't think there's a lot of commercial value in it. It's mainly attractive for detecting any like water in the lungs, or for third world countries, or. Mm-hmm. Yep. Yep. Yeah, so currently there are indeed like currently are tests being done to detect different types of brain damages in the ambulance, because it's, for example, if you have a cloth in your head, then you'll need to get stuff that dissolves the cloth. But if you have a bleeding in your head, then concussion, yeah, exactly. If you have a broken vein or bleeding in your head, then you absolutely do not want to give stuff which makes your blood even less clot-free. And time is very valuable, like time is literally your brain in that case if you have brain damage, and it's critical to make a rough diagnosis in the ambulance already. Mm-hmm. Well, actually, the currents do pass through it, but it's indeed, it's no, not only at pinholes. There's a paper out there, and they even show that you can measure brain activity with it by functionally looking in time, and then with a high resolution in the time axis, and then you can actually see that blood conducts very well because it has iron in it, and if you show people, hmm? Mm-hmm. There are ions in it. There are irons in it. Yes. Mm-hmm. Yep. Okay, if you want to be very precise, that is true. But you can easily measure blood volume by measuring impedances. And if you put in a task, so you like make you show a visual stimulus to the back of your brain, and if you can measure the impedances, you can actually see the response in the impedances back from your visual stimuli, which is then in showing that you can actually measure the internals of your brain. But it's an interesting discussion. Mm-hmm. Mm-hmm. I do think so. Yeah, I do absolutely think so. And also they need to be made more better in terms of the auto calibrations that will need to be in place, and also the three-dimensional geographic mapping of them. So in this case, it's very simple because it's just a 1D circular plane in which the distance are all equal. But if you want to do an actual scan of your lungs or say your head, then you'll just be placing some electrodes on someone, and you cannot guarantee that they are in perfect position. So you also need something for that. Cool. Well, thank you very much for listening, and I hope to show you some more amazing pictures soon. Cool, thanks.
Wat kost die chips per stuk eigenlijk? Die op zitten met alle devices.
Niet zo erg duur.
Oké. Maar dan alle hardware allemaal omheen.